Assalamualaikum and hi, welcome back to this video on chapter 4, which is on functions. So this is part 2. Okay, chapter 4 part 2, where in part 1 I have explained the introduction of function, and I also explained the benefits of function programming, or also known as modular programming, and I explained the categories of function, which are standard library functions. We have user-defined function, and we have also user-defined header files. I also explained the function elements, which are function definition, function prototype, and function calls. So in this part 2 video, I will expand my explanation on pass by reference, whereby in part 1 video I already explained the method, 3 methods in programming. In programming we have 3 methods: method 1, method 2, and method 3. So method 2 and method 3 involve with modular programming. Okay, so as I mentioned previously, I have explained on how to pass the value, on how to pass the parameter by value in part 1 video. Okay, so this time I will explain on how to pass the parameters by reference. But before we go to the explanation of pass by reference, maybe we can refer to the slide which is on page 64. Okay, the differences between pass by value and pass by reference, because in memory location, okay, every single variable that have been declared in a program, a computer will allocate one address for the variable. Okay, for example, we have x is equal to 3. We declared the variable of x is equal to 3 in a program. So computer will automatically allocate the address for variable of x here. Okay, so pass by value means we pass the value of x, for example. Okay, and pass by reference means we pass the address of the variable, for example variable x. Okay, so that is the difference between pass by value and pass by reference. Okay, what is the effect of pass by value and pass by reference? If we pass the parameter by value, if there is a modification in additional function, the actual parameter will not be modified, or will not be changed. The actual parameter is the parameter inside the main function. Okay, for example, we have here, okay, this is the actual parameter. Okay, the parameter that inside the main function, we call it as actual parameter. Okay, and the parameter in additional function, we call it as formal parameter. Okay, so pass by value, the difference between pass by value and pass by reference is that when there is a modification in additional function over here, the actual parameter inside main function will not be changed for pass by value, but for pass by reference, if there is a change or a modification in additional function for that particular variable, so the actual parameter inside the main function will be changed as well. Okay, that is the difference between pass by value and pass by reference. Okay, look at here. If the variable within the function is modified, then upon return, when what it's mean here is when we return to the main function, the value of actual variable is not modified. That one is pass by value. But pass by reference, if the variable within the additional function is modified, then when we return when the computer return to the main function, the actual variable or the actual parameter is modified as well. Okay, so that is the difference between pass by value and pass by reference. Okay, so maybe we can look at example 5 over here, and we can copy this program and paste into online compiler. So in this program, it is actually about to observe the value of x before the call, inside the function, and after the call. Okay, so in this example, there is no function prototype needed. Why? Because the additional function, which is numerical function, is located above the main function. So when the additional function located above the main function, we no need to do the function prototype. What we need is only function call and function definition. Okay, in whatever situation or in whatever method, computer will execute the main function first. So look at the main function. Okay, in the main function, there is one variable, which is x is equal to 3, and the data type of x is integer data type. Okay, there is instruction cout here. So before the call, x is, so computer will refer to this value. X is equal to 3. So that's why when you run, the output is before the call, x is equal to 3. Okay, and then there is a function call here, numerical. Okay, where where computer can knows that there is a function call, because this one is the same as the name of the function here. Okay, so computer knows that here computer needs to go to the numerical function and bring together the parameter of x. Okay, this time it is the computer will pass the parameter by value. Okay, what is the difference between pass by value and pass by reference? Pass by value, we use the name of the variable. Okay, but for pass by reference, we use the symbol of ampersand here. Okay, ampersand is referring to the address of the variable. Okay, since this one, this example is pass by value, so we just put the name of variable here. Okay, so we pass the value of x, which is equal to 3, to the numerical function. Okay, we copy this actual parameter to the formal parameter. Okay, in this example, we use the difference name for actual parameter and formal parameter. It's okay, never mind. Okay, you can use the same variable name or the different variable name. It's up to you. Okay, so the value of x here will be copied to the formal parameter n here. Okay, so now n is equal to 3. And computer will execute the instruction inside numerical function. Okay, so inside this function there is n plus plus. So just now n is equal to 3. So n equal to 3 plus 1. This one is plus 1. Plus 1 equal to means n is equal to 4. So computer will execute the cout here. So inside the function, n is computer will refer to this n. So n now is equal to 4. Okay, and then there is a return instruction here. So computer will return to the main function. Okay, computer will return will go to the line where the function call happened just now. Okay, so since the function call is in line 17, so computer will go back to the line 17. Okay, since in numerical function there is no return value, there is no returning value, because there is nothing inside the bracket here. There is no bracket, means there is no value to be returned to the main function, and the return data type here we put void. Okay, so no return value to the main function. So computer will go back to the main function in line 17 and will execute the next instruction, which is cout in line 19. So cout, after the call x is, okay, after the call x is, the computer will refer to the current value of x inside the main function. So since in the main function the value of x is equal to 3 here and 3 here, so the value of x is remain 3. Okay, so that's why the output is like this. Okay, this is pass by value. We pass the parameter to the additional function, which is numerical function, by value. Okay, so now we move to example 6 for the example of pass by reference. Okay, maybe you can copy the program and paste it on your online compiler. Okay, so in this program, the passing is passed by reference, where you can know because of the symbol ampersand over here. Okay, so we go one by one. Okay, in this main function, we assign the value of x is equal to 3, the same as previous example. So maybe we can know what is the address of x by calling its address. You just put symbol ampersand here, ampersand symbol here, x, so it will display the address of the variable of x. Okay, so this is the address. The address of x is, different laptop will have different variable address. Okay, and then alright, there is a cout here. Before the call, x is 3. Okay, the x is 3, the address is here. Okay, ampersand represent the address. Okay, the variable name represent the value, so the value is 3. Okay, so there is a function call here. So numerical x, so computer will bring together the variable of x. So the variable of x will be copied to this is a formal, this is the actual parameter. Okay, actual parameter. So the actual parameter will be copied to the formal parameter here. But in this case, we didn't copy the value of x, but we copied the address of x. So here is actually, we copy the address of x. Then the address will refer what is the value of x. Okay, I go back to the memory location. Okay, so in example 6, computer or in numerical function, the address of x will be copied to the end. Okay, we copy the address, and then the address will point out what is the value of the actual parameter. Okay, so computer will point out what is the value of actual parameter, so it will become the formal parameter. Okay, so this one, since x is equal to 3, so 3 plus 1 is equal to 4. So inside the function, n is n. N is the value of n here, so n is 4. Okay, even though it copied the address, but it point out to the value of x from the actual parameter. Okay, so 3 plus 1 is equal to 4. Okay, inside the function, n is equal to 4. Okay, and then there is actually a return instruction here. So the computer didn't bring any value when returned to the main function. Okay, this is void data, return data type. Okay, so computer will go back to the main function and will execute the next line, which is cout. After the call, x is, okay, x, the computer will call will refer what is the current value of x. Since we point out the address of n over here from the formal parameter, automatically the value of x will be changed to 4. Okay, so that's why in main function the value of x is changed. Okay, after the call, x is 4 because we copied or we passed the parameter by reference, which is the address of x. Okay, so hopefully by these two examples you are clear with the difference between pass by value and pass by reference, whereby by passing by value, the value of actual parameter is not modified, but pass by reference, the value of actual parameter will be modified as well. Okay. Okay, now I give you one more example, example 7, okay, to observe the difference between passing by value and passing by reference. Okay, so we copy this program to the online compiler. Okay, this program is about to know the number of red apple and green apple. In this program, we have one main function and we have one additional function, which is apple increment. So since the additional function located below the main function, so we need to declare the function prototype so that computer will know that in this program there is one additional function, which is apple increment. Okay, so the main function will be executed first by computer. So in the main function there is two variables, which is red and green. So the value of red is equal to 5 and the value of green is equal to 16. So there is a C out here, number of red apple before call. Of course the number is 5. Okay, when you run the program, the value of number of red apple before call is 5, yes, and the number of green apple is 16. Okay, this one is 16. And there is a function called apple increment, red, green. This is actual parameters. So computer will go to the apple increment and bring together the parameters of red and greens. Okay, so computer will go to the apple increment. So this is red apple, so the parameter is passed by value, and this one is green, and this one is ampersand symbol. So when you look at the ampersand symbol, it means that the parameter is passed by reference. Okay, so red has its own address and green has its own address. So for green, computer will copy the value. Okay, I repeat, the computer will go to the apple increment and bring together the parameters of red and green. So since the value of red is copied to the formal parameters here, and since there is a ampersand symbol here, so means the value of the address of green is copied to the formal parameter here. Okay, inside the function here, red apple, which is 5, will be plus with 4 equal to 9. So number of red apple inside the function is 9. Okay, 9 here. And this one we copied the address of green apple, and the computer will point out to the value of green apple. What is the value of green apple? Okay, the computer will find the address of green apple and the value of inside the address. So since the value inside the address is 16, so 16 plus 1 will become 17. So number of green apple inside the function is 17. So that's why here 17, and then return. So since there is no variable after return in bracket, so means that this function, the apple increment function, will not return any value to the main function, which is to the main function. Okay, so we put here void data return type, return data type. Okay, so in the main function, computer will go back to the line 14 and then will execute line 16, which is cout. So number of red apple after call, the current value of red is still holds the value of 5, because previously the passing value is passed by value for red variable, but for green since it is passing by address, so automatically the value inside the address will be modified as well, will be changed as well. So the green here is not holds the value of 16 anymore. The current value of green is changed to the 17. So that's why here is 17, because it is passed by reference in calling function, okay, in the previous calling function. So that is the difference between pass by value and pass by reference. So you can read the explanation in the process in getting the input in slide 69. Okay. Alright, now we move to the last point of chapter 4, which is the scope of variables. Okay, for scope of variables, we have local variables and global variables. So what is the difference between local variables and global variable is, for local variable, a variable defined inside a function, okay, and accessible, and the local variable is accessible to the function, that particular function only. Okay, so the scope start from its declaration and continues to the end of the block, means the scope of declaration is started at the open curly bracket until the end curly bracket of that particular functions only. Okay, whereas for global variable, a variable is defined or declared outside the function, all functions, okay, and it accessible to all functions in its scopes. Okay, and it start from the open curly bracket for the whole function, for the whole function, and until the end of the program. So maybe we can look at the example 8 here to study what is the difference between global variable and local variable. So we, as usual, we copy this program into online compiler. Okay, in this program, it consists of one main function and two additional function. Okay, so in main function, we have T1. This is function call, and there is no parameter in this bracket, meaning that the computer will not pass any parameter to the function. Okay, same goes to function T2. Okay, so computer will go to T1, okay, function call T1, and will not bring any parameter, either value or address. Okay, so go to function T1. Here is function definition for T1, and this is the body of function T1. Okay, inside the body is the declaration of variable x, integer x equal to 2. So whatever variable that declared inside the function, from curly bracket here, open curly bracket here, until close curly bracket here, we call it as local variable. Okay, only this function can use the variable of x. Okay, so cout x is 2, and y, since the variable is declared outside the function, we call it as global variable, meaning that this y can be used by another function. T2 can use this function, the y, and main function also can use the y. Okay, so y is equal to 6 means the value of y is 6. Okay, the T1 function also can use the global variable here. Global means all the programs, all the function can use this variable. So y is equal to 6. X plus plus, x just now is 2, so x is equal to 3, and y is equal to 7. Okay, and return to the main function. Okay, in main function, after the calling of T1, there is a function called for T2. So computer will go to the T2 function and will not bring any parameters because here is empty variable. Okay, so in T2, integer is x equal to 1. So this is local variable. Okay, local variable means only in T2 can use the x. So x is 1. So when we display the value of x is 1. Whereas for y, since it is a global variable, so the value is in current value. What is the current value for y? Just now in T1, the value of y is equal to 7. So it will bring the value of y, the current value of y, to here because it is a global variable. So y is equal to 7. Okay, so that is the difference between a local variable and global variable. For local variable, it can be used only within the function, the particular function, that function. Okay, but for global, we can all the function can use this variable globally. Okay. Okay, so for global variable, usually we put be above the main function, okay, so that it is more clear to so that the user can know this is the global variable, so we can know clearly. Okay, this integer y is a global variable. Okay, usually we put the global variable above the main function. Okay. Alright, so with that, I think that's all for chapter 4, where I already covered all the points in chapter 4. Okay, so I already in video 1, part 1, I already introduced the function, the benefit of function, and then the categories of function and the function elements. And then in this part 1, where I also explain 3 methods in programming, method 1, method 2, and method 3. So method 2 and method 3 involved with modular programming or function programming. Okay, so in part 1, I explained on how to pass the parameter by value, and in this video, in part 2 video, I have explained on how to pass the parameters by reference or by address, and I also explained the difference between the global variables and the local variables. Okay, so maybe you can try the exercise for tutorial, exercise 1 and exercise 2 in slide, okay, in chapter 2, in chapter 4 slide. So with that, thank you very much and good luck to everyone.